The history of development in space exploration is a fascinating narrative of human ambition, ingenuity, and perseverance. From the earliest observations of celestial bodies by ancient civilizations to the sophisticated technology that enables interplanetary travel today, this journey reflects a relentless quest to understand our universe. As we stand on the precipice of further exploration beyond our moon and into Mars and beyond, it is essential to reflect on the historical milestones that have paved the way for our current endeavors and envision the future possibilities that await us among the stars. The historical development of rockets in China traces their evolution from ancient times to the modern era. The term rocket, derived from the concept of a fire arrow, originated from the Wei state's defense strategies, which involved launching arrows with flames to deter enemies. Significant advancements were made in the rocket's design during the Song dynasty, where gunpowder was integrated into arrow construction, leading to primitive forms of rockets. These early rockets consisted of key components, such as an arrowhead, barrel, feather, and gunpowder tube, functioning similarly to modern-day rockets in their propulsion and design. Additionally, the ancient rockets found broad applications in military tactics and entertainment, with developments such as fire guns and primitive rocket-like weapons appearing in warfare during this period. In 1609, Galileo Galilei revolutionized astronomy with his invention of the telescope, significantly advancing our understanding of the cosmos. Although he did not invent the telescope itself, its origins trace back to earlier designs in the Netherlands. Galileo was the first to improve its magnification and utilize it systematically for astronomical observations. His most notable enhancements resulted in an instrument capable of magnifying objects up to 30 times. With this powerful tool, Galileo made groundbreaking discoveries, such as the moons of Jupiter, the phases of Venus, and detailed observations of the lunar surface, fundamentally challenging the geocentric view of the universe and laying the groundwork for modern astronomy. Launched on October 4, 1957, Sputnik 1 was the world's first artificial satellite, marking a significant milestone in space exploration at the beginning of the space age. Developed by the Soviet Union, this iconic metallic sphere measured about 58 centimeters in diameter and weighed approximately 83.6 kilograms. Sputnik's launch ignited the space race between the United States and the USSR during the Cold War, capturing global attention. It transmitted radio pulses back to Earth, which were detectable by amateur radio operators and scientists alike, providing valuable data above the upper atmosphere. The satellite's successful orbit around the Earth every 96 minutes challenged perceptions of technological superiority and sparked advances in science and engineering on both sides of the Iron Curtain. The event catalyzed the establishment of space programs worldwide, leading to satellite technology's development, laying the groundwork for future exploration, including the moon landings and the ongoing quest to explore other planets. Yuri Alexeyevich Gagarin, born on March 9, 1934 in Klushino, was a Soviet pilot and cosmonaut who made history as the first human in space. On April 12, 1961, he orbited Earth in the Vostok 1 capsule, marking a significant achievement in the Cold War-era space race. His background was humble. After experiencing World War II as a child, Gagarin pursued education in math and physics, eventually attending the Soviet Air Force Academy. Chosen from a good group of fighter pilots due to his small stature, he underwent rigorous training before his groundbreaking flight. Gagarin's mission included a famous shout of Poyakali, meaning "off we go." Despite some technical difficulties, he completed the orbit successfully and parachuted safely back to Earth. Gagarin subsequently became an international icon, celebrated globally, earning accolades like the prestigious title Hero of the Soviet Union, embodying the spirit of human exploration in space. On July 16, 1969, NASA launched Apollo 11 with astronauts Neil Armstrong, Buzz Aldrin, and Michael Collins on a historic mission to the Moon. Just 4 days later, Apollo 11 approached the lunar surface. Collins stayed aboard the command module Columbia, while Armstrong and Aldrin entered the lunar module Eagle to descend to the Moon. They faced a tense landing in the Sea of Tranquility, with only 20 seconds of fuel remaining. When the Eagle safely landed, Armstrong became the first human to step onto the Moon, followed by Aldrin. They planted the US flag and read a plaque dedicating their mission for all mankind. The astronauts collected 47 pounds of lunar samples before rejoining Collins in the command module. Apollo 11 returned to Earth on July 24, 1969, marking a milestone in space exploration, with subsequent missions sending more astronauts to the Moon until 1972. Pioneer 10, launched by NASA in 1972, was a groundbreaking unmanned spacecraft that made history by passing through the asteroid belt and successfully conducting a flyby of Jupiter on December 3, 1973. It became the first spacecraft to capture close-up images of the gas giant, revealing vital data about its liquid composition and magnetic field. Originally intended for a 21-month mission, Pioneer 10 far exceeded expectations, operating for over 30 years and transmitting its final signal to Earth in January 2003 from a staggering distance of 12.23 billion kilometers. The spacecraft's objectives included studying Jupiter's atmosphere, magnetosphere, and its moons, particularly Io. Its successful journey paved the way for future explorations of the other planets. Following its Jupiter encounter, Pioneer 10 continued towards the star Aldebaran, with an estimated travel time of 2 million years. Until the launch of Voyager 1 in 1998, it held the title of the most distant man-made object in space. The Space Shuttle Columbia, launched on April 12, 1981, was the first orbiter in NASA's Space Shuttle program, marking a significant milestone in space exploration. Its maiden flight, known as STS-1, lasted for 54.5 hours and successfully deployed into low Earth orbit. The shuttle orbiter, named after the historic ship that explored the Pacific Ocean, was designed for reusable flights, combining the capabilities of the aircraft and the spacecraft. Columbia was constructed to carry out various missions, including satellite deployment, scientific research, and International Space Station assembly. During STS-1, Commander John Young and pilot Robert Crippen orbited Earth 37 times before landing at Edwards Air Force Base in California. The successful completion of STS-1 demonstrated the viability of the shuttle program, paving the way for subsequent missions and advancing our understanding of space. Columbia flew a total of 28 missions before its tragic loss during re-entry on February 1, 2003. On August 25, 1989, NASA's Voyager 2 spacecraft achieved a historic milestone with its close flyby of Neptune, marking humanity's first detailed view of the eighth planet in our solar system. This encounter completed the Voyager's mission's grand tour of the four giant planets, Jupiter, Saturn, Uranus, and Neptune. Notably, Voyager 2 revealed Neptune's striking blue color, resulting from methane in its atmosphere, and uncovered a massive storm referred to as the Great Dark Spot, alongside the discovery of 6 new moons and 4 rings. The probe also conducted a close approach to Triton, Neptune's largest moon, which exhibited active geysers indicating geological activity. Overcoming the challenges posed by Neptune's distance and low light, the team used enhanced communication methods to transmit high-quality images back to Earth. Ultimately, Voyager 2's mission extended beyond the flyby, as both Voyager probes continue exploring interstellar space, enriching our understanding of the cosmos. The Hubble Space Telescope, launched on April 24, 1990, aboard the US Space Shuttle Discovery, marked a significant advancement in astronomical observation. Designed to operate free of Earth's atmospheric interference, Hubble was conceptualized in the 1940s, constructed in the 1980s, and despite an initial setback due to lens aberration, it quickly began to deliver stunning images of the universe after a successful repair mission in 1993. Orbiting the Earth approximately every 97 minutes, Hubble boasts a resolution 10 times higher than that of ground-based telescopes, allowing it to capture unparalleled views of cosmic phenomena, from comet impacts to distant galaxies and black holes. Over its decades-long mission, Hubble has not only produced breathtaking visuals, but has also collected vast amounts of data, offering vital insights into the nature of the universe. His contributions have reshaped our understanding of space and time, revealing wonders previously confined to human imagination. The advent of the MESAT-1 and MESAT-2 satellites marked a significant turning point in Malaysia's telecommunications landscape. Launched in January and November of 1996 respectively, these satellites were pivotal in breaking the government monopoly on communication services, previously dominated by Telekom Malaysia Berhad. MESAT-1, Malaysia's first communication satellite, enabled direct-to-home television and expanded broadcasting options, leading to the emergence of Astro as the first subscription-based pay TV service. The satellites utilize advanced technology, including gallium arsenide solar cells and lightweight antennas, enhancing their efficiency and power delivery. MESAT-1 originally operated at 91.5 degrees east, while MESAT-2 functioned at 148 degrees east, providing extensive coverage across Asia and beyond. Together, they revolutionized how Malaysians consume media and communicated, transforming entertainment and telecommunications in the country. Tiongsak-1, Malaysia's first microsatellite, was launched on July 21, 2000, marking a significant milestone in the nation's journey into space exploration. Weighing just 60 kilograms, this innovative satellite was developed through a collaborative effort between Malaysian scientists and engineers, along with support from the UK. Tiongsak-1 was equipped with various instruments designed for Earth observation, notably contributing to environmental monitoring, disaster management, and urban planning. The satellite operated in a low Earth orbit, allowing it to capture high-resolution images of the Malaysian landscape. Tiongsak-1 not only served practical functions, but also inspired a new generation of local engineers and researchers, catalyzing interest in space technology within Malaysia. Its successful operation paved the way for subsequent satellite missions, reinforcing Malaysia's commitment to advancing its capabilities in space science. The National Space Agency of Malaysia, known as Angkasa, was established in 2002 with the goal of fostering the country's space program through coordinated efforts to develop and apply space technologies. The agency aimed to enhance Malaysia's capabilities in the space sector for national development and security, aligning its initiatives with Vision 2020 and beyond. In 2019, Angkasa merged with the Malaysian Remote Sensing Agency, rebranding itself as the Malaysian Space Agency to improve synergy. Notable achievements included the Angkasa-1 program, which successfully sent Sheikh Muzaffar Shukro, Malaysia's first astronaut, to the International Space Station in 2007 through a collaboration with Russia. This initiative was designed not only to boost national pride, but also to inspire a greater interest in science and technology among Malaysians, particularly youth. The International Space Station program was a collaborative effort among 5 key space agencies: NASA, the Canadian Space Agency, the European Space Agency, the Japan Aerospace Exploration Agency, and Russia's Roscosmos. Officially approved in 1984 under President Reagan, the program began to take shape as international partners, including Canada, Japan, and European nations, were solicited for cooperation. The ISS design process spanned from 1984 to 1993, and its construction commenced in the late 1980s. A critical phase, NASA Mir, occurred between 1995 and 1998, involving 11 space shuttle missions to the Russian Mir orbital spaceship. The second phase started in 1998, marking the ISS assembly. Eventually, the space station got completed in 2011. Over time, the ISS has become a vital platform for scientific research and technology testing, focusing on areas like human psychology and material science, while also serving as an educational tool to inspire future generations in STEM fields. In conclusion, the evolution of space exploration has transformed our understanding of the universe and our place within it. Breakthroughs in technology have enabled missions to distant planets, stars, and beyond, revealing the mysteries of our cosmic neighborhood. As we stand on the brink of manned missions to Mars and the establishment of lunar bases, the future of space exploration promises not only to expand our scientific knowledge, but also to inspire future generations to dream beyond the stars. That is all. Thank you.